Personal finance practice problem using Excel. Excel functions related to present value, future value, and number of periods. Problem number 3. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information's on the left-hand side. Going to populate that into the blue area on the right-hand side. But before we do, note that we do have some hidden cells in this worksheet. You may have hidden cells in your worksheet. We'd like to practice unhiding and hiding the cells and then think about the different formats that we've looked at in prior presentations for these types of calculations. Not that you need to do them here to follow up with the calculations in the Excel worksheet, but just to get an idea of the different methods that can be used. So in order to unhide these cells, we're going to put our cursor on column B, left click on it, drag over to column L, let go, right click on the selected area and unhide those cells. So we have the information in column A now that we see here. The yearly earnings percent in a savings account, we're going to say is going to be 18%. Now, again, that's high for a savings account, but we're imagining that there's going to be an increase in some kind of investment of that 18%. You can have a similar kind of thing if we're talking about investments in stocks or investments in a home that's going to be increasing in value. We then calculated how long it would take for it to double using the rule of 72, which was around 4 years. We then estimated the beginning balance of $3,000, thinking about how long it would take to double to get to, in other words, $6,000 if it were to double. We did so using then our calculation for a yearly calculation of interest, and we got between 4 and 5 years, which is around the same thing we got for the rule of 72, which is an estimate. Now we're going to do the same thing with regards to our functions in Excel, noting that when using the functions, probably the best thing to use, or what you would use most often if you were in practice, but you still have the limitation of the functions giving you kind of a magical answer, such as 4 over here, similar answer, without giving you kind of the detail of what you can see if you actually make the table, which will give you the calculations of the interest on a yearly basis. So this kind of table format still is useful to do. Now we're going to hide some cells. We're going to hide these cells again to practice that. So what I'd like to see is this data on the left-hand side right next to where column L or column K here. So we're going to hide the columns. So I'm going to go back on over to the right. And you could, if you want to see all the columns at one time, go down here and make this a little bit smaller, bring it down so I could see everything at once. And now I'm going to be hiding from C to K, putting my cursor on column C. So I hit the drop down, dragging over to column J, letting go then, right-clicking on the selected area, and then I'm going to go ahead and hide the selected area. So there we go, we hid it. So now we got our data right next to our data input. I'm going to make this a little bit larger down here again. I'm at 220. I'm going to make it as large as I can to make it as easy to see as possible. We're at the 280. All right, so now we're going to go ahead and do the same thing with our present value, future value calculations. The most direct function to do this is actually the number of periods function, but that's also probably the most or least well-known function. When you work with present value and future calculations, you're probably more familiar with the future value and present value calculations. Let's start with those and think about how we could use them in order to back into the number of periods in a similar way as we can do with a mathematical function that has an unknown in it that's not basically the name of the present value. Kind of like if we use the present value formula algebraically, we can back into some unknown as long as we only have one unknown. Same concept here, although we cannot rework a function, we can basically use that function to kind of figure out the unknown by using a tool called goalseek. So that's what we'll do here. Now, here's our present value. Let's start with the present value. This is probably the first one people work with when they think about these kind of formulas. That would imagine that you have some number out in the future that you're trying to pull back to the current time period, taking into consideration time value of money. So we're going to use our present value. We're going to imagine then if we're trying to think about how long it would take for something to double using our present value to do that, we're thinking that the end point then would be doubling this 3,000 to 6,000 and then pulling it back to the current period with the discount rate of the 18%, seeing how long it would take the distance then in time to do so, and that would be the number of periods. So let's kind of figure that out. Let's start off here with the present value, and I'm just going to type this in. Note that you could, and we did this with the first practice problem, go to the formulas here, look at the insert function to look at the insert function at table. I'm not going to do that for these problems because I'd rather just type it in, which is probably the best way to do it once you get used to these formulas. And so that's what I think the best practice to actually do would be. So I'm going to say equals, and we're just going to type in present value. You could double click on the present value down below or say Shift 9 to put the brackets around it. Now we have our arguments down here with the rate, the number of periods, and so on. We're going to be picking up the rates. I'm going to try to do this navigating with the arrow keys in Excel as opposed to pointing with the mouse so much because this is the third of a similar problem. So I'm going to go up, 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 right, left, left, up, up to the 18. And then notice that this little dialog box moved up. You can actually move it back down if you want to place it wherever you think is appropriate. Then I'm going to hit a comma to move to the next argument. That's the number of periods. That's the unknown. That's what we do not know. So we can do two things here. I can look for another function for the number of periods, which is going to be the number of periods function, which will be Excel kind of reworking it as you would think to do algebraically, solving then for that component. Or I could use the function that I know, present value, and use the goal seek to figure out the unknown component. So what I'm going to do is just choose this cell down here, which doesn't have anything in it but will populate soon, get the answer, and then we'll use basically goal seek to kind of back into using trial and error what the answer should be. Then I'm going to say comma again, and then we got the payment. Now payment is a term that would be used in these present value functions if you have an annuity. This is not an annuity, present value of 1, so you can either put 0 and a comma or more professionally just simply 2 commas. Then we want the future value. The future value where we end at would be the 3,000 times 2 because it's going to be doubled 6,000. So in other words, we're going to give the value of 6,000, discount rate at 18%. How long would the distance be in time then to get to the 3,000 present value component? So we're then going to say then this is going to be, I'm going to do the cells down, left, left, up, 3,000 times 2. Notice I'm not hard coding the 6,000. I'm not going to close up the brackets. You could, but you don't need to because Excel will do that for us. I'm going to say enter, and there we have it. Now this number is not accurate given the fact that there's nothing in this cell. So then you'd want to populate something in here just to make sure that the function is calculating properly. So I'm going to put something like, what if I put 10 in here? Now we're at this 1146. The result in a present value will typically be negative. What you want oftentimes is a positive number. If you want a positive number, double click on it. You could then put a negative number before the payment amount or the future value amount. But I like to just put it in front of the P here, taking the whole function and in essence multiplying it times -1. So I just put a negative right there. And then we get a positive 1146. Now we know what the end result should be. The end result should be, we're trying to do a present value. So we started off with 6,000 to bring it back to 3,000. So we need it to be 3,000. So I could say, now I'm just going to adjust this cell down here to get closer to the answer, to the 3,000, right? If I get 9, like 7, let's like 6, and so on. And then I can use Excel to use that trial and error kind of method to back into the unknown being the amount in this cell using goal seek. So we're going to go up top to the data tab to do that. We're going to go to the forecast group. We're going to go into the what if analysis and goal seek. Goal seek. And then we're going to ask Excel, we're going to say, would you set this cell right here to be what we need it to be, which we know is 3,000, by changing then this cell with the 6 in it. Let's get to the cell with the 6 in it. And so we'll ask Excel to do that and say, okay. And there we have it. And it changes it to the 4.19, which is more exact than we saw with the rule of 72. And I'm just going to say, okay, that looks good. Now we can do the same thing from the future value kind of equation standpoint as well. So in the future value kind of thing, where we would start, we're imagining we're starting at 3,000. We know what the endpoint should be, which is 6,000, and we want to know how long it would take basically to get there. It's just going from the other direction. So let's look at this formula. We put our cursor in here, equals, that would be the future value. Now you could double click on the FV, or I could say Shift 9 to give us our dialog box down below. And then we're going to pick up the rate, which I'm not going to type in as 0.18, but rather I'm going to use my arrows left, 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 up to pick up cell B2. You could move this back down again, but note once I hit the comma, it moves it back down in essence for us. And then we've got the number of periods. That's the unknown. We don't know the number of periods, which we're going to just pick up by populating this cell, which has nothing in it currently. That's the one that we're going to adjust to get to the proper number. Then we're going to say comma. This payment represents if it were an annuity. It's not an annuity, so we're going to say comma, comma to go to the next argument. The present value then, that's our starting point, the present value, which is the $3,000. I'm going to get there using the arrows, down, 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 left, left, left to the 3,000. You could close this up, Shift 0, but you don't need to because Excel will basically do that for us without giving us any problems. So I'm going to say OK. There we have it. It's not proper right now because once again, there's nothing in this cell. Let's estimate the 10 again. Now we've got a negative 15,702. I'm going to change the sign of this, double clicking on it, which you could do by putting something in the present value calculation, a negative number, in other words, or you could put it in front of the F, which I'm going to do here. I'm just going to put a negative in front of the F. There we have it. Then I'm going to change this cell until I get this number to what it should be, which I know if it's a future value, it should be twice the 3,000 because we're trying to double it, or 6,000. So it's too high. So I'm going to say, well, what if I said like 8 here, 7, 6, and so on. And then I'm going to ask Excel to continue that process by going to the Data tab, going to the What If analysis and the Forecast group. And then we're going to say Goal Seek. We're going to seek the goal. We want to set that cell to be 6,000 by changing this cell. So please change that cell to whatever it needs to be, Excel, to make that cell be what we need it to be, twice the 3,000 or 6,000. So we're going to say OK, and Excel does it, and there's the 4.19 again. So we just did the same thing from kind of the opposite direction, showing the relationship, hopefully, between the present value and future value calculations. Now, the other way we can do this, of course, is say, well, why don't I just see if there's a function in Excel that's for the NPER, which is the unknown that we're solving for using the goal seek. So that's the next method we'll do up here. And we're going to say, all right, that's kind of like reworking it algebraically. Although we can't do that ourselves, we can see if Excel has created another function solving for that component, which in this case they have, of course. This equals the NPER. Double-clicking the NPER, or we could just hit Shift 9 to go into it. We have the rate then. Once again, the rate, I'm going to go over to the 18, not hard-coding it in, but going left, left, left down to the 18. Then I'm going to say comma, payment. PMT stands for payment. There is no payment here because this is not an annuity. The payment would be for an annuity. So just simply comma. The present value is going to be our starting point, which is the 3,000. Now, this is a little bit tricky. Excel's going to want us to have that as a negative number. I'm not going to do it now. I'll put the negative in later just to show you what will happen. It'll be frustrating if you're not aware of that. And then comma, the future value we also know because that's double the 3,000 or 6,000. I'm not going to type in 6,000 because I want to pick this up from our data set. So I'm going to say down, 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 left, 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 times 2. Then again, we could close this up, but we don't need to because Excel will do it for us. So I'm going to say enter. Now it gives us this number problem saying we have a problem. That I'm interpreting that to be like we got a problem. So I'm going to double click on it. Now, if there's a problem with these functions, it's usually that Excel wants a negative number somewhere, which we kind of solved down here by putting a negative sign before the n. That's not typically where you want it here. You want to put it in front of the payment one, I think, the present value item. I'm going to put a negative there, and then I'll say OK, and now it gives us the proper answer. So those are the 3 ways we can kind of see, hopefully, the relationship between these future value, the present value, and the number of periods functions in Excel. Notice, even using it this way, we're still got kind of this magic number that pops up here, and we don't get to see the interest actually compounding as we do with the running balance that we saw last time. That running balance still quite important. Next time we'll take a look at this, a similar thing using the actual equations so we can think about how to do it mathematically, and then we'll think about how to use tables, which is often used when you're thinking about book problems.